Hello dear students. Today I'll be discussing about types of propagation. Types of propagation. Before that, we should know what is propagation. So, let us move on to the next topic, that is the introduction to the propagation. Propagation in a transmission line refers to the movement of an electromagnetic wave along the line. As you can see, in case of transmitting any signal, suppose two antennas you are having, one is your transmitting one, another one is receiving one. From the transmitting antenna, the signal will be transmitted, and through the medium it will propagate, and finally it will be received by the receiver. Now, at this time, when your signal is moving, or I should say traveling, this signal is nothing but electromagnetic wave. How the signal is moving along this line, this is called propagation. This thing in a 3D, you can plot it like this, where this side we have kept the electric field, then this side we are having magnetic field, then the direction of the propagation in this direction. Mainly when any transmission is occurring through an unguided media. Unguided media means what? Wireless communication you can consider. Means there is no wire. So when we are transmitting any electromagnetic wave through an unguided media, there how the signal is propagating, what are the way they can propagate, that is important. Depending on the propagation, we are having different types of unguided transmission, we can say, or else we can say for unguided transmission we are having different type of propagation. So from here you can see, when a voltage is applied to the input of the transmission line, an electromagnetic wave is generated that travels along the line, carrying energy and the information. In data communication and networking, there the communication and the data which we are saying, the data we want to communicate, that this thing used to be carried by something and needs to be travel, and then it should be reached to the receiver end. In between, the wave will propagate. So the movement, simply the movement of this electromagnetic wave, that is your signal which is having some information, when it is moving along the line, then we are saying this is propagation in transmission line. Now next comes the types of propagation. The type of propagation, you can see there are mainly three types. The first one is ground propagation. See, here I have mentioned this word, unguided media. The unguided media propagates electromagnetic wave from source to destination in three methods. The first one is ground propagation. In the ground propagation, the signal used to pass between the ionosphere and the earth's surface. Here, as you can see, two transmitting antennas are placed. One is definitely the transmitting antenna, another one is the receiving antenna. From the transmitting antenna, we are sending the signal, and the signal through this medium, and this medium is where it is placed. It is between the ionosphere and the earth's surface. And where our antennas are placed, they are placed on the earth's surface, this in the ground. So mainly the signal is transmitting between this region I should say. That's why we are calling it as ground propagation. This in ground propagation, mainly depending on the or I should say in ground propagation, this wave, this electromagnetic wave follows the curvature of the earth. The way, suppose if you are having the earth like this and you are having one antenna here and one antenna here, so this signal will be transmitting like this. It will follow the curvature of the earth, and from this transmitting one to the receiving antenna, the signal will be sent. Here one more thing we should keep in mind, that when you are sending any signal, how much the signal will travel, the distance, like one antenna is placed here, another antenna is placed here. Now what should be the distance between these two antenna? That depends on the strength of the signal or the power of the signal. More the power, more the signal will travel more distance. Okay, so here you can see this point. In ground propagation, the electromagnetic wave is propagated close to the atmosphere, that is between our ionosphere and the earth's surface. That's the thing. Next point, you can see that electromagnetic waves which are propagating through ground propagation, they are of low frequency waves and they can be transmitted in all direction. Basically, when we talk about radio transmission, radio signals are omnidirectional, like this. Okay, in all direction it will spread like this. Okay, so it's been spreading in all directions. This is called omnidirectional. So these are mainly some low frequency waves transmitted in all direction, and it follows, as I said, that curvature of the earth. More the power of the signal, longer the distance this signal will travel. So this is all about ground wave propagation or ground propagation. Now some advantages we can see here, some points. In the advantages we are having, like the factor of large bandwidth. Obviously, if there is less frequency, the bandwidth will be large, and if you are having, bandwidth not, this wavelength will be large. If you are having large bandwidth, then the attenuation will be very less. Now what is attenuation? Attenuation is any kind of loss of energy of the signal. If the signal strength is dropping or any part of the signal is being cut from the system, from the signal, then we are saying this is attenuated. Okay, some loss. If you are having larger wavelength, then the attenuation will be less. Okay. And in this ground wave propagation technique, the signal loss due to atmospheric condition is less. Some disadvantages are also there. So in the disadvantage, you can see the distance between the transmitting and the receiving end must not very large, because it's not possible to get very high power signal. To get very high power signal, you need very high power or very big structure antenna. That's why here in this ground wave propagation, the distance between the transmitting and the receiving end must not be very large. The operational frequency range is generally up to 2 megahertz, which is very less. Okay. But I said, as frequency is very less, so wavelength is higher, larger, and less attenuation. So here are some application, as you can see: signal broadcasting, target detection for military purposes, radio signal transmission, and wherever in those means you need some distance sort of operation in local range. Obviously in local range, there we can use this ground wave propagation. Why we have said actually local range? Because if the distance range is higher, then definitely your signal strength should be, or the signal power should be higher, and in such case the structure of your antenna and other accessories should be larger. So that's why in the local range generally we use this one. The next comes the sky wave propagation. And sky wave propagation, the electromagnetic wave which is propagating, it is having higher frequency compared to the ground wave propagation. It is having higher frequency, and this higher frequency electromagnetic wave is radiated up in the ionosphere. See here, from this transmitter to here it has been radiated, and from the source transmitter antenna, when it has been radiated here, from this point again, sometime here we used to have satellite sort of thing. Practically, if I say, some satellite sort of thing is there, so it used to catch this signal and it used to amplify generally and send it back to the receiver. And where is the receiver? Receiver is in the earth again. So why it is called sky wave propagation? Because you're propagating the signal in the sky, and from the sky it gets reflected back to the earth surface. Okay. So as you are sending this one from here to here, this which is having very longer distance, so in sky propagation, signal electromagnetic wave can be received thousands of kilometers away from the transmitter, because it's traveling like this pattern. Okay. So this is sky wave propagation. Here also we can highlight some disadvantages. Here the frequency range is generally high compared to the ground wave propagation. Attenuation due to atmospheric condition is less. And it supports definitely large distance propagation. Now when we are sending long distance propagation, as we said, it will always require some large sized of antenna. Okay. And due to the presence of the ionosphere near and far, during night and day, there should be some existence of variation in the signal transmission. In daytime there will be signal transmitted, or the strength will be different, and the night time it will be different, so some variation will occur. Okay. So here you can see the applications. The application mainly in mobile and satellite communication, here I have highlighted. Okay. So which we know it about satellite use and all, so there we use this skywave propagation. Next one is line of sight propagation. Here as you can see, the transmitter receiver antenna is placed here again in the earth, but here this signal is in straight line. Generally this is having the highest frequency. First, ground wave propagation is having 2 megahertz, then the sky wave propagation is higher than that one, and line of sight propagation is having the highest frequency, we can see. That's why it's been written very high frequency. Okay, but it is transmitted in straight line. That's why the word came, line of sight. Here if you are having, suppose, this dish type antenna, these two should be in face to face. Suppose if this antenna is in this direction, then not like this, okay, like this direction, then it can't take the signal. It should be always in the line of sight, in the straight line facing each other, then only signal can be transmitted. Okay. Now what is the helpfulness of this thing? See, when we are sending signal using the curvature of the earth, there could be some effect on the signal. Okay. So here what we can do, we can have either tall suppose antenna, or maybe we can place the antenna above some buildings and all, so that we can maintain this line of sight. And many times we can see these things we used to do. Okay. So the electromagnetic wave doesn't get affected by the curvature of the earth, because the transmitter and the receiver antenna are either tall or close enough to maintain line of sight, means straight line. Okay. See, this one is placed like this, they are maintaining like this. You can see some examples. Suppose there is a mountain. So here if I want to place, or if I want to send signal, suppose from A area to B area, then what I have to do, I have to place this this antennas like this. So from here it will be traveling like this. Suppose one antenna here, from here straight line. See, these are all straight line like this. So this side you can get it, but it should be always in straight line. Okay. In detail, if you see the propagation modes, how we used to propagate it. This is some images I have collected from some internet sites only. So I have already given those sites name in the reference. I'll show you. So here you can see this is the different propagation modes. In the ground propagation, suppose you are having antenna, here signal is transmitting like this, so it will go like this direction also, this direction also. See here, the signal is traveling along the curvature of the surface of the earth. And next, see in the sky propagation, here one antenna, here one antenna. So this from here signal is being propagated here and it is received here. Okay, or like this you can see. And here we can place some satellite to receive from here, from transmitter to the satellite, and satellite to again here it will be received. Line of sight of propagation. See here, if you can let me, if I can enlarge it little bit. Yeah, see what is the facing of the, like this, face to face. So there should be some direct line, straight line will be there. Okay, in between two antenna, that is the transmitter and receiver, so that signal can be passed. Here we are having high frequency. See the ranges. It is below 2 megahertz, it is 2 to 30, and here it is above 30 megahertz. Okay, so this is, I think, clear. See the two antennas as placed like this, so that you can have straight line in between there. Okay. This is all about different types of propagations which we use in unguided transmission media. And here are some references I have taken for the pictures and the theory which I collected and the idea I got. So thank you all. Next time with another topic we'll discuss, and do let me know if another topic, what topic actually you want to hear from me, so that we can discuss in the next class. Okay, thank you all.